My name is Barry Lindler. I teach computer science at Dutch Fork High School here in Irmo, South Carolina. This will be my 27th year teaching, I believe. I teach AP Computer Science A, AP Computer Science Principles, Computer Programming 1, Computer Programming 2. And back in the day, I taught AP Computer Science AB back when that was a course, one of my favorite courses. Wish they'd bring it back. I've been at Dutch Fork for 24 of those 27 years. Love that school. I'm also our assistant AP coordinator, and we have a STEM honors academic magnet, and I'm the director of that program at our school. Our school has about 1,600 students. We traditionally are one of the top performing schools in the state. So don't knock us just because I'm from South Carolina. Our kids do some great work. In fact, what you're going to see today is actually some work of one of my students. And we're going to shift gears a little bit. You're going to be a student actually working just some on code, and it's not so much the features and intricacies of coding rooms as it is you would see how I would interact with you as a student and how you would actually perform those assignments and those tasks. So what I'm going to do in the chat, I'm going to put a link to our live classroom and have you join in. I can find that link.
Perry, I shared that link with everyone else too on the live chat.
Okay, good. All right, yeah, so if y'all will join, and you'll start seeing on my screen that you're coming in. And like Joe showed you earlier today, and John was hinting to in his, you actually don't even need the Zoom sharing part now, because what you're going to be seeing is actually just within coding rooms. So near the top of the screen, you're going to have some options. You can look at just my presentation, or what we recommend is that you look at the presentation and your workspace side by side. So you'll have presentation and workspace with a line underneath it. So if you'll click that, and you should be able to see your screen and mine side by side. Joe and John both had mentioned earlier templates, and I set up a brief template for you. So you should already have some code that's editable like you see on my screen. And what I'm going to do is just show you some simple graphics and a quick way to do some animation with students. I've heard people mention Pygame and some other libraries. What this particular student did for me is back when, before I started teaching Python in our computer programming 1 class, I used a library called Projectile, and it was kind of nice, had some basic shapes, and you could do some pretty advanced animation, but it was still a simple tool, but you could use it in some advanced ways. And then when we made the switch because of the pandemic, we switched to Python for some of that remote learning. We were using Turtle Graphics like a lot of you have used, and some of you have mentioned yet today. But I found it kind of limiting. It had some neat things, but compared to what we were doing, it didn't do enough. So what this student did is he wrote his own graphics library called Pydraw. And he gave me all the tools that we needed. So it's built off of the concepts of Turtle, but it goes a lot more advanced. My 3rd and 4th year students have done games with this, such as Tetris. We've done an interactive animated Scrabble game, that sort of thing with it. So you can get really involved, but it was designed from the very beginning to be quick and easy setup for students so that you could start at day 1. And as you'll see as we go through this one simple little game together, how you can stop it at any point, and you can determine that's the depth that you want to go with your class, or you can make exceptions or different assignments based on the ability of individual students. We all have those students that are your top shiners and those that can barely even copy and paste in our classrooms. And so this works in that environment because it gives a support feature to those students that struggle, or those students whose attendance are maybe not as consistent, or those students that like to listen and not do, or the other way around, that student that likes to do and not listen. It gives that kind of that live interactive feel, so you can adjust to each one of those modalities and try to address those students. Now, I do also want to say that this doesn't work for every assignment. And my way of teaching is kind of what you're going to see. We tend to do everything together to a certain point, and then you will hear me talk about today, this is where I would have stopped. And their assignment would have been to fix this problem we just uncovered, or spend 10 minutes together with the group trying to find a solution to this or that or the other. So it's kind of a switch gear from what John was showing you. It's not an assessment type thing. It's more of an interactive group project that we were doing together. All right, so in this one, if you will notice in the files section, you should also have a Readme. And I put a Readme in all of my assignments. And I generally have discussions with my students like we are discussing now, but we all have those students that want specific things listed out. So I will list them for them just to make them happy. John had mentioned that he doesn't plan an awful lot in advance, and I'm not one of those huge advanced planners. I know where I'm going, but I'm going to be changing things for tomorrow, tonight. So that's just the way I do. But I have learned that I do need to give some specifics to those high flyers that really want kind of checkoffs. I also use this to give them some resources, and you're going to find here 2 resources that I wanted to draw to your attention, which are links to this graphics library and the documentation that my student wrote. What I'm very impressed with him is that he went to a lot of time and trouble to make sure that the documentation is accurate and thorough, and that there's some quick starts and quick, easy examples to get people going, so that you can put some students on this library and they can just go on their own. Certainly you would want to direct them, but if you have those students that just need more time to explore, then they can read these examples, use some of the samples themselves. It's also good exercise in reading technical documentation because it's very accurate. He was also very careful to try to adhere to industry standards. He and I debated for hours at times on how things should be written and what would be the proper style since you're writing it from scratch. He also wrote what he calls a sister library called Pydraw that we're going to look at later on this afternoon. We're actually going to do the exact same assignment, but with the Java twist to it. And I'm going to talk about that more, how I would do that with my AP Computer Science A students. But this is just for my Python students, my first year students. So anyway, those links and all this stuff is in that README. And then we've got the file. Now, depending on your learning style, if you want to watch and then move over my code, you're absolutely welcome to do that. Joe had mentioned earlier today that when you're in a live classroom like this, you can go into my file and you can copy and paste directly to it. You can independently scroll through it all you want to. I did not give you rights to change what I've written, but you can copy and paste it into yours. You have to decide if that's what's best for you in your classroom. You certainly don't want a whole year of students just copying your code, but you also have some students, that work at a different speed. And that's actually kind of a handy feature that they can focus a little bit, or when they get stuck, they can go back and kind of get caught up. And my students know that I want to see their style, not my style. All right. So we're going to write a little game today, and we just call it Launcher. It's the old type shoot 'em up game. There's just going to be some objects bouncing across the screen, kind of like the old asteroids or brick breaker type thing, moving across the screen, and we're going to launch some things from the bottom. Now, I'm very careful with my students. I don't allow them to use terms like shoot and bullets and guns and stuff like that. But we've all know what kind of game this is, but this is just a launcher, just hitting things and changing colors and stuff. All right. So what I would do first, and again, I'm going to go through this and tell you key points where I would stop with my students. But the first thing I want to do to get on the screen is just a little box that goes right and left. So first thing in Python is just going to say it's box, and it's going to be a rectangle. And in his particular pattern for his construction, we always tell it the screen. You just got to tell it where the object's going to be. You notice I gave you the screen to start with. And we'll talk about this loop in a minute. All right, so we do that. Next thing I'm going to do is tell this box where I want it to be. So I'm going to put it 1010, and I'm going to make it 2525, and I'm going to make its color red. Again, you're welcome to follow along, copy and paste, or type as we go, either way. All right. Now, I always tell my students to run constantly, run constantly. We want to leave code always in a working condition. Nothing worse than going in behind a student and these, 50 lines of code and none of it has ever worked. So we like them to run constantly. So when something's broken, we know right away. All right, so we see it right down there at the bottom. So our box is up and going. So now I want to make this guy move. Well, down here, we have just a simple loop. And all I'm going to do is tell my box that I want it to actually move. Now, movement is pretty easy. We can just simply do a box.move, if I can spell. And I can tell it the direction I want to go. Now, we would have already had this discussion, but in Pydraw, just like most standard graphics, the origin is upper left-hand corner, that's 0, 0. So increasing X is to the right and increasing Y is down. So if I want it to move to the right, I want to give it a positive X value, such as 5. And I don't want it to move it all down. I just want it to go 0. Now, when we get ready to run it, we're going to see that's going to be a problem for us. Is that I don't know how to make him come back around. So that leads me to a quick discussion with my students that it really shouldn't be 5. It should be kind of a reference point, a variable. So I really would have just used direction for this so that I can change that direction, so I can steer it. So then because I have direction, I need to go above and declare it. And I know it seems kind of weird, but I always do like a +5 in something like a direction to make them think about, okay, I'm actually wanting that thing to go into the positive direction. That's just my style. And I would also have them add a quick note up here what this actually does. So this is going to move the box. So here we go. Woo! Exciting times, I know. All right, next thing I want to do then is make this box bounce off the side. So I'm going to make me another note here called bounce box. And then I know I need to have those conversations. If you haven't talked to them about accessors and mutators, this is the perfect time to start talking about it, or you can just give them the information and talk about it later. But in this situation, I'm just going to ask the box. I want to know if your X is going to be greater than the width of the screen, or if your X is going to be less than 0. And if that's the case, I want you to reverse your direction. And then we'll have a quick math discussion. How do you get the opposite value of something? So that can either multiply by -1, or typically what we do is just direction equals negative direction. Now, some of you are already seeing some problems, and we know that's coming up, but that's the way I teach. I like them to explore and see their own problems. Like you saw, it went too far off the screen on the side. Again, for your more advanced ones, they can do what we call clean up the code, or we can clean it up now. But I'm just going to leave it for us for right now. And just as a reminder, what I would be doing if you were watching my screen via Zoom as opposed to your workspace, I'm going to flip over to student workspaces and I can see what's going on. I can look at all those real quick, take a quick gander at who's doing what. I can also see when the last time people have been active in their particular environment. So I would be looking at this. The students wouldn't see it, but that's just the way I would be doing it. All right. Now, not only do we have it bouncing, but I also need to make it move down. So our students, we would have that discussion is when should it actually move down? And we should say as soon as it bounces, that guy needs to move down. So I'm going to put a little note of move box down. And that's going to be a box.move. In this case, we'll do 0. And we can start talking about accessors again. So I might want him to move his exact height plus a little bit. So since I'm going to do it that way, I'll just ask the object for his height. And I always like to add a little padding, and I have them write it out as a number so I can actually see it. And we'll test it and make sure that we are now hitting each side and bouncing. We are, and it's starting to wrap. Everything's looking good. Now, those of you that are familiar with Python know that when you don't need to change a value, like with moves and not changing the X value, I can actually just do a dy equals box.height, and it fixes just that particular value. Again, you just use some standard notation when you wrote this library. Or depending on what you're trying to teach your students, whether you want to put the actual parameters there or not. It's totally up to you. Again, however in depth you want to take this particular package. All right, our next step then is to add multiple objects. If it's your first few days of class, you might not want to do multiple objects. You might be ready to go ahead and do the part of the launching, and which we'll talk about that in a minute. Or if they're a little more advanced, you can talk about collections. So I'm going to go the collection route. So I'm going to then convert what I've got up here, and I'm going to make a box collection and call it boxes. Well, if I could spell boxes. And then I would have a discussion again, wherever you are in your educational process. I would do quick loop. And then I would just take that temporary box I just made and append it to my boxes. Now, you and I know, and some of you are already catching on, you know that all this is going to do is make 5 of them right on top of each other. And only one of them is going to be moving because we've got all kind of problems going on with what we've done. So first thing we need to fix is then how to spread it out. So it allows me to talk about this variable for I, because we're using graphics, we can get out of the mathematical part of it and do something they can actually see. This is why I need to change that number. And if I want to spread the X out, we would eventually come to the conclusion, then I need to vary the X. And so right here is where I can put my variable. And I want that variable to adjust a certain amount. And so in this case, I want to go the width of the box, and I want a little bit of padding. So I'm going to do that plus 10 again. I know it looks a little weird, but I like to teach them to spread those numbers out, because when they clean this up later on, these things will become variables instead of just hard-coded numbers. So this would be called box padding and that kind of thing. All right, so we've now got them spread out. And you see the advantage of coding and testing and coding and testing. We don't have to go any further. We can already see we got a problem with the movement. Only one guy is moving. So I go down here in my notes, and since my notes are right, I clearly see what the problem is. I'm moving a box, not moving the boxes. So if I need to move the boxes, it gives you an opportunity to talk about loop structures again, and in this case, the enhanced loop. So we'll do for box and boxes. Which will now move them all. And now we got to deal with this part, this moving down. All right, the way I've got it written right now is moving down is based off of bouncing. Yeah, once it hits the side. But I don't need to move just one. I want to move them all. So that kind of tells me again that I need another enhanced loop. So what I can do then is use another enhanced loop. So for box and boxes. Then move that guy down. Now, the other issue we're going to have, again, we can stop at this point for your beginners. You know, they can go ahead and start interacting with the game and do some other things, but your more advanced are going to start to realize wait a minute, if we're bouncing off the left side and the right side, we don't need to be looking, this guy, we need to be looking at just the box on the left or just the box on the right. So what I would have them do is define two temporary boxes. I'd call one of them left, and that will be boxes 0, again, based on the level of your student. And box right would be boxes, and that'll be the length of boxes -1. And so you could have had a whole day of instruction on how did you come up with these values? Where did that come from in this collection? Why is it important to reference them by where they are in the collection as opposed to hard-coded numbers? Then I can just change these to be the appropriate box. All right, now we have them all moving. Now, some of you that have done Pygame and other things already know that we are still going to have a big problem. That once we see that that object going, it's going to, when we're going to start removing them, it's going to start being a problem because that box 0 is not going to be there. But that's where one of those advanced things that's your other students can deal with on their own, or you could have leave them at this point and say, hey, how are y'all going to address that issue? All right. Notice I'm holding 2 because if you've got those students that have been listening to you or paying attention, it gives them a kind of a maybe about a minute to kind of catch back up. We want them in a working state. I would be now glancing at student workspaces, looking to make sure everybody is where they need to be. I'm not trying to bring any of y'all out because some of you really just want to observe, but that's why I'm pausing, because that's how I teach. Give them a couple of seconds to get caught up. And if they need to copy my code at this point, they can, because we're just trying to learn together. All right. Now that we have that, we need to start dealing with our launcher. And this gives us some other neat tools that my student's name is Noah, by the way, that Noah has written into Pydraw for us. Our launcher is just going to be a barrel looking thing towards the bottom. So I'm going to go up near the top of my code, and I'm going to define a launcher. And it's going to be nothing more than a rectangle. I can spell. It's going to be on the screen. And then now I need to think about where this thing is going to be. I want it at the very bottom of the screen, pointing straight up. So it's going to be in the center. So they need to do some math. So they can do screen dot width divided by 2. Or what Noah has given us is an attribute for the screen, and all of our objects, by the way, have this attribute, is the center. So you can actually find the center of any of these objects, the rectangles, triangles, polygons, custom polygons, whatever. He calculates the center. And I can get just the X of that if I want to.
There, sorry to interrupt. We have a question from the teacher. If this is able, are we able to do this with Python Turtle module?
It is not going to be nearly as streamlined. Now, I think if you will use this for a while, I think you will find that this will do everything Turtle can do plus more. But Turtle's not going to be able to do everything that Pydraw can do. Pydraw right now is pre-installed with coding rooms, but it's in the link I gave you. You can download it. You can pip install it into any Python environment and use it. It's going to behave very similar to Turtle, but you're going to find it's a lot more robust. It does a lot more advanced things. So in fact, even the game I'm showing today is extremely simple. As far as comparing to Pygame, I've only looked at and read about Pygame and used it a little bit. The comments I hear is that Pygame goes pretty well to begin with, and then all of a sudden it gets very, very deep and very heavy. And I don't think that happens with Pydraw, because you have a little more control over and some restrictions on how things work. Okay. All right, so let's go back to our launcher. Thank you for those questions, and thank you for bringing that to my attention.
No.
And I'm going to make mine just 50 by 300. Whoa. Right. Now I've got a problem that most of your students are going to have too. Notice that it should be at the bottom of the screen, and technically that's right because all objects are anchored at the upper left-hand corner. So it's actually below the bottom of the screen. So then I would always have them do this in 2 steps. I tell them always that centering is a 2-step process. And I'm just going to have them move the launcher a little to the left to center it. Wow, I am struggling with typing today, y'all. Sorry about that. And I'm going to have them move it up half of its height as well. And now we should be able to see our launcher. Okay. And yes, David, Pydraw is already pre-set up for you in coding rooms. You just need to use that import statement at the top from Pydraw import star. And if you want to do it on your own, that the link I gave you in the README has all the directions. It's available on GitHub. If you use Python and use pip install, it's through that system as well. So it's just a quick pip install and it'll set it up for you. All right, so now I have my launcher. And what the deal is this guy's supposed to be pointing at where I want to launch towards. So we know then, those of you that use turtles, you know that there's things called rotations. So we can technically rotate this guy. So let me show you another little trick. I'm going to create a quick function so you can see how easy it is to use the mouse. So we got a function and it's defined as mouse move, and it accepts a location. That location is the actual location of the mouse. And I want to tell my launcher, I want it to rotate. Wow, we're still struggling. And I'm just going to say 5 right now. Now in Python, you have to tell it to listen for screen events. So we're going to add a little line down here called screen.listen. And see how that thing now is just rotating. So for something to rotate, it means it has to have a direction. And those of you that have used Turtle, you know a turtle has a default direction. I think it's to the left. We decided our default direction is actually just up. So what we're going to do then on our mouse move, instead of having him rotate, we want him to look at where my mouse is. So we actually wrote a function called LookAt, and I tell him where to look. I want him to look at wherever the mouse is. So when I run it now, my object can be looking at the mouse. So I can do that with other objects. One object can look at another one so it can steer itself if you're doing a spaceship type game. And if you didn't want to teach that, you could have taught the rotation. You could get into the math of calculating the X and Y, and you can do sine and cosine and arctangents and do all that kind of stuff, which you had to do in the background, or you can just simply use this LookAt feature. All right. Now that we have that, we need to create some projectiles. So I would have a discussion with the students is, when do you want this projectile to actually be launched? And they should say, when you press the mouse. So we're going to use another function, and this mouse down, and it has two different parameters because it's involving the mouse itself. It has a button parameter and the location. So you could technically figure out which button you're pressing if you want to, or you can just ignore it, but you have to have that in there for the header to be correct. Now what I'm going to do then is create a projectile. And this projectile is going to be at an oval. The construction pattern is the same as the rectangle. Tell it we want it on the screen. And then we have to talk about where do we want this thing to be. And hopefully your students will say, I want this to be on top of the launcher. Well, then that means use an accessor for the launcher. So I'll say, hey, launcher, in fact, why don't you give me your center? And I want your X value in particular. And hey, launcher, I need your center again. Can you give me your Y value? So that's going to put it right in the center of our launcher. If you remember, our launcher was very tall. You saw it when it was spinning. It's actually centered on the bottom. That gives us kind of that, so it gives that pivot look to it. So that's why we're putting it at the center. It's technically at the very bottom of the screen. And I'm going to tell it I want it to be 20 by 20. And let's just give it a color of green so we can see it. We can also do color numbers if we want to. Then we would normally have a discussion about, hey, if I create this one projectile, how do I control it? There's, I can't, every time I click the button, if I have one new one, it's got to be moving like the boxes were. So it leads us to create a whole new collection. So instead of us having that discussion we just did in one sentence. So I'm now going to go up and make another collection, and this is going to be for our projectiles. So I'm going to add all of our projectiles to this collection. And now I'm back in my mouse down function. And I'm going to say to the projectiles, I want to append that projectile I just made. And I'm very particular about my names with my students. I don't let them use shortcut, silly names. I like them to be a little wordy since most things have that auto completion for you anyway. So now as I'm clicking away, we would again have some more explanation that all these projectiles we're making, but they're not moving because we never told them to move. So we now have to go back into our animation here and have a whole new section to deal with making those projectiles move. So I'm going to just follow my same pattern, make me a quick note, move my projectiles, and then hopefully they'll recognize, wait, this is very similar to the boxes issue. So I'll say for projectile in projectiles, I want my projectile. And in this case, I can tell my projectile to move forward. Because remember, I told you that these things have that rotation direction I was talking about. So these projectiles, when they're created, are pointing up automatically. If I did not want to go into all that, I could still just do a normal move command. So now they're going, but you notice they're not following my launcher. And I'm intentionally demoing this a little bit long. Again, it allows students in class that need a little more time or to go back and look at my code a little bit. It's allowing them to kind of get themselves situated with what I'm doing. All right. So now we would have the discussion that those projectiles need that orientation or that rotation set so it knows what direction to go in. So then we would have a discussion about when do you do that? And we were going to actually set that when I create the projectiles right up here. So right before I append it, so I'm in my mouse down again, I've created my projectile. Now I need to point it in the right direction. So I want to tell my projectile, I want your rotation to be the exact same rotation as the launcher. So you're pointing or looking at the same direction that the launcher is. And so now when I clicked, which that launcher was pointing to the right, my projectile is pointing to the right. Again, it's not going to be perfect. If I'm moving this thing too fast, it's going to be it's going to kind of slide out the side, but now it kind of follows around. Now, if you think about what we've done in just a short few minutes, we got some more to add, but we've had some really great theory discussions already. So this could be a first year class, second year class, first day class, first year class, anywhere you want. And because the graphics and implementing them are so simple, you've got them hooked because now they want this game to work. You know, it's different than trying to find an average of numbers or doing that sort of thing. This has got them hooked on, and it's just rectangles going across the screen. Okay, now, last thing we got to do then is actually hit the boxes. So I'm going to ask my students, I would say, okay, I would ask them to look at my code so we all have the same line number. I say, where in there would be appropriate? Where in that animation part, we would have a long discussion about this while loop here. Where in this while loop is appropriate to find out if something hits something else? And hopefully they'll say when the projectile is moving. Now they literally could do it the other way around. They could look at the box running into a projectile, but in this case, we're doing the projectile going into the box itself. So right in here, while we're moving the projectiles, we're also going to look and see if we've actually hit something. So right here, I'm going to add a note and say check for hits. And then we know we've got to go in each of the boxes. And now I'm stuck because I don't know. I guess I have to do the math. I need to find the X of the projectile and the Y of the projectile and the X of the rectangle and the Y of the rectangle and the width and height and do the math. And in class, we would actually do the math for the first one and they would hate me for it. Because then I'd say, okay, well, seems like that's kind of a standard thing. We might want to be able to do that in a different way. So I've now used this to teach some theory and then show them the purpose of encapsulation and writing functions that can be reused. So let's actually use what's given to us. In this case, we wrote one that's called overlaps, and it checks all available pixels to see if any of those pixels overlaps the other one. So now we could then go back and delete their code, which they get very mad about this. All right, I get paid to make them angry. I want to say if that projectile overlaps the box. Now, for right now, we're going to get into removing the box, but all I'm going to do is just have the box change color so I can see it happen. And I'm going to show you how we can just do numbers if you want. There's also a color.random that just picks one of the random name colors if you want to. All right, starting to turn gray. Now they immediately want to say, okay, I want this thing to explode. I want all kinds of things to happen. And that's your little hook there for your more advanced ones. So the code for some could be, okay, now you need to do some type of animation based on that collision, or you need to do blah, 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 blah. We've got more work because we've noticed that when that projectile hits, it continued to hit. It was like a super projectile, and it was actually just kind of going crazy. And I'm going to prove that to them this way. I'm going to say, you might not notice it, but that projectile, it went right through those guys and it continued to hit. And so if it was actually causing an explosion or something, one well-timed projectile would wipe out that whole line. And that's not really how we want it to do. You AP Computer Science A teachers, don't pay too much of attention about what I'm about to do. Python lets me do it. We're going to do some illegal things with this enhanced for loop and remove things in a collection while we're manipulating it. But that's a discussion for the Java section later. But one of the first things I want to do then at this point is get rid of the projectile. All right. Now notice again, we're just simple to our students that we're teaching. Projectile.remove just removes it from the screen itself. It doesn't actually move it from the collection. Now we know that because we're programmers. They don't know that. They think if you can't see it, it's not doing anything. Then I'm also going to remove the box. Now we know this is also going to cause me some problems. We're going to get some concurrent modification issues and things like that. But for now, it's going to let us actually see it working. And there goes my concurrent modification. It doesn't always happen, but sometimes it does, and it makes a mess. And that allows you to have that discussion. Hey, what are we doing? What can we do to solve this problem later on? So what I'm going to do then is just take out that box.remove, actually projectile.remove, so that we don't have that error anymore. But again, it allows them just to explore some. All right. One last little piece I wanted to show you then is how we can also update some text objects so they can see what's happening. We can do some simple print statements, of course, but I'm going to just show you a quick and easy way just to make a little text. I'm just going to call it status. It's going to be a text object on the screen, and it's going to count the hits. So I'll tell it what I want it to say. And for now, I'm just going to put it at, I'll just put it up at 1010. I'll make its color random color. Wow. And I'll give it a size of 32 so that we can actually see it. And then I'm going to make me a little counter called hit count and preset that to 0. And that's what this is going to show me, is every time I hit a box. Again, would ask the students to tell me, where do we know we've hit a box? And they should take us all the way down here to where this was happening. There's all kind of stuff in here. I would actually have them probably write a function for this. And so at this point, we're going to have our hit count go up by 1. And then I'm going to update my status just by restating what I want it to say. And adding to that in Python, we're going to convert it to a string, but hit count. Sorry about that. It's my concurrent modification issue. I'm doing bad. Still doing bad. Messing up. Oh. Let me take him out. All right, there, that way the hit counter now is showing them clearly what's happening. They can actually see that number going up and know I haven't launched that many times, that guy is just getting rapid fire through there. All right, again, perfectly solvable solutions for them. And Usha, yes to the multi-threaded games. You actually can, and we're going to do a quick key event now, just so you can see how that works as well. So just for, we won't actually go all the way into the reset, but let's say, for example, we wanted to do a key for resetting. So the function is called key down, and it takes the key as its argument. And all we have to do is ask if that key happens to be the letter R, then whatever you want it to do, such as print, you hit the R, I will reset. Which resetting, those of you that have done games with your students before, resetting's really involved, which is a really cool discussion of how to fix everything. You can't just like slam things back because things have been on the screen and not on the screen. But as I press it now, you can see in my console over there that it's actually working. And yes, you can't tell because I'm not on camera, but I'm smiling because your next question was actually the last thing I wanted to show you is images work great in this. All of your objects can also be images. So these projectiles could actually be, we sometimes do a variation of Fruit Ninja. I tell them what they're doing is you're trying to build Skittles. So they're throwing fruit towards these boxes and whatever color the fruit is, that those box, the box becomes that color and you're making a Skittles pack and all. But let me show you how quick and easy we can add an image. In coding rooms, they make it very easy over here on the file section. I'm just going to tell it I want to upload a file and actually have a file ready called space. And now it's already in there. And the command is very easy. It follows the same format. It's very peculiar about making sure this is very consistent. So on the screen, I'll put this image called space.jpeg. And I can tell it where to be and how big to be. In this case, I'm just going to have it 800 by 600. You can do all kinds of other things with it. And it works. This was another really good selling point for me when I made the switch to coding rooms last year, is just how well this is running in a virtual environment. For my 3rd and 4th year students, when we really talk about what they're literally doing right here, and in some cases on their phone, and this is running on another server somewhere. And now we've just uploaded, this was a 3K video image. It wasn't even a shrunk down image. I mean, it's a full-fledged desktop image from my Mac, and it's running it fine, and it can manipulate it. And for us to have this layer of complexity. Now we notice I can't see my launcher because I built the launcher first. I can adjust layers, all that's built into here. So it's a very extensive library. I would highly recommend you look at it. If you start with simple little shapes like I did and just having them move around, your students will tell you what they want to learn. They'll say, hey, this thing is bouncing around. Can we hit it with a paddle like a Pong game? And you'll say, okay, well, let's figure out how to do it. And you can keep a tab open. You can look at the documentations. You can look at the extensive samples he's given you, the animation, and you can just create your own concepts. We will take something like this and we'll discuss a theory and then use this graphical environment to specifically talk about sorting and searching and collections and that sort of thing. And yes, your students would need to upload their own space.jpg, and you have access to that in your individual workspace right now. I don't know if they can, Joe, you might have to help me about the forking. I don't think they can fork my presentation, but they can, can't they move the file from my file?
Yeah, so not in the live classroom, forking is disabled. That's only for assignments in the live classroom, forking is disabled because those tend to be more secretive, kind of part of the course areas. The regular workspace only has that students freely create. However, you can go over to Barry's presentation, look at the files, click the 3 dots to download it, and then upload it to your workspace.
Absolutely.
Barry could have, if he predicted he wanted to use that particular image in this lesson, he could have included it with the template also, and everybody would have had that image to when they got to that point in the lesson.
Absolutely. Thank you, Joe. The students really like that idea of this workspace. And just to clarify how the workspace itself works, since this is a live classroom, when I leave it today, I'm not going to actually do that except Joe showed you that earlier. I will leave it so it stays there. Students can still go back into this thing later and access their work. But if they want to copy it into their own workspace, they would actually need to do a download or a copy and paste. And Tom, that was the same thing. You can at this point, you can download that PY file you just wrote by using the down arrow in your file collection. And I'm not going to terminate this live classroom for probably a good month. So you can always come back into it when the session's over. You can still look in my stuff, which again is a great resource for your kids that are struggling in the background. And because it's graphics, I don't know what it is, the kids just, they will do the work if it's a moving box. They won't do the work if it's just a line of code sometimes. But anyway, I will answer some more questions. And just for those of you who are thinking about later on in the afternoon, the Java session, I'm going to be using this exact same assignment, but focusing more on how we've written some of the methods to be a little more AP oriented, and how I teach it a little more in the AP style, just a few more comments that we have about what's going on, how we deal with that concurrent modification, since Java will actually stop it from happening, where this just lets it crash, and difference between a compiled language and interpreted language. Great. Thank you, Tom. Anybody else have any questions of it? And like Joe said earlier, if you want to reach out to me anytime afterwards too, as a teacher and a convert. Joe's the one that hooked me on the coding rooms months ago. He just crossed paths on Facebook, and he was talking about it, and I looked at it, and it was a perfect answer for my solution in my classroom. So I'm just really excited about another year. We bought the full package last year, and we're going to buy the full package again this year. And I've got 2 other co-workers in the district that we're also moving to coding rooms. It's just a good it's a good equalizer for all your students. You give a student a Chromebook and coding rooms, something that can run graphics this smoothly, and then everybody's on the same playing field.
Absolutely. Never do you have to worry. Of course, there's some case situations, but most students have access to something with internet, and coding rooms can run on, as long as it has internet and web browser, it can run.
Yes, sir.
While Barry's typing in his contact information, I do want to point out that Enzo did provide the exit survey. You want to make sure you do that to get credit for each of the sessions that you're participating in today. At the end, they'll send you a nice PD certificate totaling the hours for each of the sessions you participated in. So make sure you click on that form and just complete that for us. We're entering our break now from 1 p.m. Eastern time to 2 p.m. Eastern time. We're on a nice little lunch break, or whatever you need to do break. We will return with assignments and auto grading in Java, as well as Barry's going to show off graphics and animation with Java using
JavaDraw.
What do they call it? JavaDraw.
Yes, sir.
His student that developed, which is if you've noticed, this library is very powerful yet easy to use and amazing. And his student Noah did an excellent job with both these for Python and Java, and they transfer so well. So if you do like an earlier course with Python, and then you transition to AP CSA, and you do Java, or you do some other Java course, it just works so well. So definitely consider this using these libraries. But we're going to be doing that, as well as assignments in JavaScript and checking out p5.js. And we'll end with block coding in Visual Studio Code and some of the more intricate and unique features that Coding Rooms has to offer.